So as your wavelength increases or decreases, if the speed stays the same, your frequency will change. So for instance, if we think about radio stations, radio waves all travel at the same speed. How do you get different radio stations on your radio? Well, you change the dial to a different frequency. How do we get that different frequency? Well, the radio stations will broadcast their signal in a different wavelength. So they're able to create different frequencies by using different wavelengths, knowing that the sound, that the actual wave, the radio wave itself, has a constant speed. All radio stations go out at the same velocity, the same speed, but by using different wavelengths, they're able to create different frequencies. And then your radio has a receiver in it that's able to receive that wavelength and then unpack it for you in terms of turning it from a wave going through the air into a sound that you can actually hear. And that's kind of fun to think about as well. But let's not get ahead of ourselves. Let's talk about the longitudinal wave. Now, longitudinal waves, the language is a little different. Again, this is figure 11.2 straight out of your book. A longitudinal wave, you've got these compressions. When you create a compression, the compression moves across the wave. And so they're trying to illustrate that with these three pictures. Notice first you have the wave at time 1. There's a compression all the way at the far left edge. There's a compression a little offset center to the left. And there's a compression a little offset center to the right. Then if we look at the same wave, time 2, which is sometime later than time 1, everything's moved to the right. The direction of the wave is in the horizontal. That's the direction these compressions are moving. You could actually watch the compression move across in that video that we saw, excuse me. And if we look at it a little time later, wave 3, sometime after wave 2, again, they've moved further to the right. So the propagation is to the right. But the compression of that wave is also in the same horizontal direction. So the whole wave's moving this way, but the compression of that wave is in that same direction. Compressed horizontally, moving that compression horizontally. By definition, that's a longitudinal wave.